another problem, and today's problem is validating an IP address. What we are doing basically is we are validating an IP address. We will be given input as a string, okay, and we have to check whether this particular string is an IPv4, IP version 4 address or not, okay, IP version 4 address or not. How we are going to solve this? Our task is to validate an IP address and return true or else return false. Okay, so that means our function will be a Boolean function. Boolean function, okay, a Boolean function which will have a string input, okay. Now it is telling the characteristics of an IPv4 and IPv4 address, okay. So what are the characteristics? It is saying that canonically can represent in dot decimal notations, which consist of 4 decimal numbers. Okay, so there will be 1, 2, 3, 4 decimal numbers which are separated with dots. Okay, and each number can each of them range from 0 to 255. That is what it is allowed. Okay, separated by dot. A valid IP address is of the form x1, x2, x3, x4, where I told you all are 4 decimal numbers. The decimal numbers has to be greater than equals to 0 and has to be lesser than equals to 255. Thus we can write the generalized formula as 0 to 255, 0 to 55, 0 to 55, 0 to. Here are considering numbers only from 0 to 255, and additional leading zeros will be considered invalid. Say for example, somebody over here gives as 10. Okay, then it is not a IPv4 address. So a number which has no leading zeros, we have to trim the leading zeros, and then we have to solve the particular function. Okay, so and also we have to do this in O and time complexity, which is a very important aspect. We can check the examples. There are 4 numbers which lies till 0 to 255, therefore it is a true. Over here you can see this does not lie between 0 to 255, and the representation is also incorrect, so this is not a valid IPv4 address. So what are the algorithms? What are the algorithm which we will be following? Okay, we'll be making a couple of functions before doing this. So our first function is, suppose we have a class. Okay, we have a class, so I'm just going to write the abstraction. I'm just going to write the features of the functions which are required. Okay, and when I'm coding, I will be giving you the inner part of the function. Okay, so my first function is as given in the template, is a boolean is valid. Okay, a boolean is valid, which will be containing a string, say str. Okay, string str. Now we are going to check whether it is an IPv4 or not. So we are going to return okay, return is valid IPv4. So we'll be making a function is valid IPv4 somewhere over here, and then we'll be passing the same string. Okay, and our main function is done. Now we have to make the other functions. So say for example, we are making a boolean IPv4 function, which is going to check whether it's an IPv4 or not, IPv4 function or not. Okay, so in this what we are going to do is, first condition is if the string is null. Okay, if the string is null or the string is empty, then we are going to return a false. So first is to check whether string is null or not. String is null or not. The second condition we are going to check that whether the string is empty or not. So string cannot be empty. String cannot be empty. Okay, so we have taken the two conditions, whether it can be empty or whether it cannot be null. Okay, now last we are going to check if the length of the string is not 4. Since an IPv4 is separated, is total of 4 decimal points, so if the length of the particular string is not 4, if there is no if there are not 4 elements, then it's also not possible. So we have to check the length of individual values as 4 or not. Okay, so we can check the individual values lengths as 4 or not. Okay, after which we can see is after which we can check whether the part is alphanumeric or not. Okay, so we can check the part as alphanumeric. Okay, we can check the part is numeric, so we have to give only numerics. We cannot be alphanumeric, we have to give only numeric, so we will make a separate function of a numeric somewhere else. Okay, what else do we have to check? We have to check our number lies greater than equals to 0, and the particular number has to be lesser than equals to 255, which is one of the base cases. Okay, now this part is done. Now I'm going to make another function which is checking whether it's a numeric value or not. So I can call this as is numeric. Okay, in is numeric, what I'm going to basically do is I'm going to pass the string. Okay, and then convert Sorry, there's some response from the server. Yeah. So whether I will check, I'm going to check convert the string to number. Okay. So once I'm done with converting the string to number, what else I can do? I can also check whether it's an IPv6 or not. So I will have, for additional test cases, check IPv6 version 6 or not. So for IP version 6, my length has to be, if my length is lesser than 3, and if my length lesser than 3, or my length greater than 8, then return false. Okay, so this is the conditional for IPv6, which is right now not required, but we'll be requiring it at some later point. Okay, because these are our all test cases. Okay, we have to check all the test cases. And IPv6 values are not, suppose over here only one decimal places for IPv4, but in case of IPv6 we can have two dots like this. So we cannot have anything more than 2 dots. Okay, lastly we will have a function to check whether it's a hexadecimal number or not. So is hexadecimal valid, we will check. Okay, and yeah, so hexadecimal numbers are from A to F. So this is for IPv6 conditions, but as per we will be doing IPv4. But in case if we get IPv6, how we are going to handle it, those are the edge cases. Now we are going to code the particular solution. Okay, so if you see I've already coded it over here. I will show you the particular code. So first we are checking public static boolean is valid. We are passing a string. We are returning the OR operator of, we are checking is valid is either IPv4 or either IPv6. Okay. For IPv4, we are first checking whether the string is null or the string is empty. Then we are going to return false. Then we are going to store it, the parts, in an array, string array, which each part is separated by a dot. If the length is not, so if there are not four integer values, decimal values, then we are going to return false, as already discussed. After that, what we can see is we are going to check the numeric part, whether it's a numeric value. It cannot be ABCD. We have to check the numeric value. If it is not a numeric value, or if the part length is greater than 1 and the part length is, or the character is say 0, as I already told you, there shouldn't be any leading zeros, then we are going to return false. Or else we are going to take the number, we are going to store the integer part of that number and check. If the number is lesser than 0 or the number greater than 255, then false, or else it will run successfully with the true function. After that, we have a boolean is numeric function check. What will it check is basically it will check whether the number is a new number or not, or else we are using it inside a try and catch block to give a number format exception. Okay, we're doing basic exceptional checks to have the code working more efficiently. Lastly, this is for IPv6. For version 6 IP address, we are first storing the values in with double quotes. Okay, with what the double decimal values. Okay, and we are checking the base cases, parts less than 3 and parts greater than 8. After that, we are checking whether it's empty. Then we are checking the empty count. We are also checking whether it's a hexadecimal part. IPv6 should not have more than one double colon and must be handled accordingly. That's the reason we are returning empty count less than or equals to 2, and this is the condition for IPv6. We will be having a valid hexadecimal character check. So hexadecimal numbers lies from A to F. After 0 to 9, then A, B, C, D, E, and F, like that. So we'll be having an hexadecimal check over here. Okay, and this is the hexchar function, which is going to return the character greater than equals to 0, or the character ASCII value of the character is lesser than equals to 9. So remember one thing, whenever we are denoting a character within single quotes, we are checking the ASCII values. Okay, so this was today's problem statement, and the main function and the main code which lies in this entire thing is this IPv4. If it is an IPv4, our code is going to successfully work. So thanks a lot for watching, and we are looking forward to solve more videos and more problems. Thank you so much. And don't forget to like, share, and subscribe to the channel.